Okay, good morning. Welcome to
FamilyMath973.
FamilyMath973. So you made a really interesting shape using the function parametric plot. And we were using this shape to kind of explore a trig function. So first of all, tell me about what you did with the x, y, and z coordinates here, and what you thought was interesting when you were playing around with them.
So, let's see. So the x-coordinate is 2 cosine of t plus 2 minus cosine of 3t.
Okay.
Y-coordinate is 3.2 sine of t divided by 2.
All right.
And the z-coordinate is 2 sine of t minus 0.6 plus tan of t.
Plus tan of t. Okay.
And then the tube is 0.5 thick. T goes from 0 to 50 and 1,000 plot points.
Yeah, and it looks also like you might have a cosine of t multiplying all of that.
Oh, yeah. So
Was that just an accident, or was that there intentionally?
I think that was just an accident.
Oh, okay. Well, all right. Well, cool. It sure made a neat shape, though.
Yep.
So let me tilt. Actually, can you scroll down on the mathematics instead of tilting the camera? We'll just bring the shape up, and you can. Yep, there is really good, and you can move it around and tell what you thought was interesting about this.
Let's see. Well, I thought there is definitely symmetry in here, like twofold symmetry here. I thought it was neat that it sort of when it went out like this, that it just came back and then did the same thing again, and then it kept looping around. And I was surprised the loop stopped so quickly.
Oh.
That was kind of what I was trying to do to make it less complicated.
You were trying to make it less complicated, so you had some prior versions that were
More complicated.
more
They're
complicated.
going to be harder to actually make.
Okay.
But with this, the tan of t, I was surprised because the tan of t can go very high and very low, so I thought it would be sort of like monsters.
Uh-huh.
But it's not for some reason.
Yeah. Now, why don't you bring your formula back down and see if you can see what happened to cause the tangent of t part in the z-coordinate to not be so crazy. Do you know what happened?
Well,
There's a good thought that adding that tangent might have made things really blow up, but it didn't. So something happened.
so when it's not a direct tan of t, it's not just that it's going to be added to 2 sine of t minus 0.6.
Right, but when that tangent of t goes, where will tangent go to infinity? What's one example?
So when sine, or like when your angle is pi over 2, then tan is undefined, so just before that.
Yeah, so right around there, maybe you might be adding 1 to it or something, or 2, because it's 2 sine of t, so the most you could be adding or subtracting is 2. So if you're adding that to infinity, it's not going to really make that much of a difference. So it's not the addition that made the difference.
But, let's see, if you're multiplying it by cosine of t, because when tan of t is really big, the cosine gets really small. So when your angle is pi over 2 radians, then cosine of t is 0.
Mm-hmm.
So I guess, so actually that also cancels out the undefined parts as well. So when this goes undefined, it multiplies it by 0, so it brings it back to 0.
Aha, so what do we have ultimately? What's the product we have there?
Tan of t times cosine of t.
And what is that?
So it would just be sine of t.
Aha.
Because tan of t is sine of t over cosine of t.
Yeah, so that extra cosine t had multiplying everything there, which may have been there just by accident.
Mm-hmm.
Actually
Helped a lot.
helped a lot. Yeah, it's really cool. All right, good. Let's take a look at your shape because we 3D printed it. Okay?
Alright.